Okay, we have here the digamma reflection formula on the board. We've got digamma 1 minus x minus digamma of x is equal to pi cotangent pi x. And I want to derive this formula. And what I'm going to do is I'm going to start with Euler's reflection formula with the gamma function. So the formula we have for Euler's reflection is going to be just gamma of x times gamma 1 minus x is going to be pi over sine pi x. So to start with, we'll use Euler's reflection. What I want to do is I want to take natural log on both sides of this equation. And then for step 2 on this, it's just going to be log properties. Here we're multiplying two things, so we can break that up and turn it into addition and have natural log gamma x plus natural log of this other one, gamma 1 minus x. And then on the right side, again, log properties, we can turn this into a subtraction and write it as natural log pi minus natural log sine pi of x. And then the next step's kind of interesting. What I want to do is keep in mind the digamma function is related to the gamma function through the derivative, actually through the derivative of the natural log. So if I take the derivative on both sides, this is going to be nice. So what I want to do is take dx on the left side on the left side and do the same thing on the right side. So doing this out, we could kind of leave it, but let's actually differentiate it. So if we differentiate natural log gamma of x, it's going to be like 1 over gamma x. And then we need the chain rule, so then the derivative of this, we can write this as derivative of gamma of x. And then same kind of thing on this one. We get gamma 1 minus x. Chain rule, we get derivative gamma 1 minus x. But then chain rule again, there's a minus sign on the x, so let's take this and change this to a minus over here. And then on the right side, ln pi is just a constant, so that gives us a 0. Over here, we get a minus sign. Derivative of this, we're going to have 1 over sine pi x. Chain rule is going to be cosine pi x. Chain rule again, a pi pops out, and so we have a pi right here. Then let's get this 0 out of the way. That's not helping us. Then just kind of by choice, let's change the sign. We'll reverse the sign by multiplying in by minus 1 on both sides. So doing that, that's going to cancel that there. And then we'll just reverse the sign on the left side. And then from here, let me make a little space. Let's look at the definition for the digamma function and see what we can do from here. Okay, so here's our definition of the digamma function in terms of the gamma function. And like I said, we could have left it as we had this a minute ago, and I just differentiated it to this. So what we're saying is this right here is an exact match for digamma of x. And then this one over here, same kind of thing. This one's going to be digamma of 1 minus x. So putting this together, let's just reverse the order. So what we have here is going to be digamma 1 minus x minus this one, digamma of x equals pi in front. Cosine over sine, that's just cotangent pi of x, and that's going to be exactly what we wanted. That's going to match our formula. Okay, that's it for today. Thanks everyone for watching. Have a good day.